So can you guys see my screen now?
Okay. Yes, sir.
Okay, so before we proceed to the assignment, okay, so do you guys have a question so far, or concerns or clarifications? Anyone? Okay, so it seems that no one of you has a question, so let's now proceed to the slide 28. So let me just open my Visual Studio. So as I'm saying yesterday, so we will only finish the looping part. So we will not proceed to the input and output, okay, and then the catching error, or is that error handling? Okay, we will not proceed to that one anymore, okay, because we don't have that much meetings left. So I would like you guys to use the remaining two meetings this coming Friday and Saturday, because as far as I know, the start of your final exam is this coming June 15 already, if I'm not mistaken. So it's 15, 16, 17. Or if not, I think it's 16, 17, 18. I'm not really sure, but your final exam is already on this coming uh, next week. Okay. All right. So don't you guys worry. We now only have a few more slides left. So after maybe two parts of meeting, and that's already it. We will not be having a part three anymore. All right. So let's answer this assignment right here. Assignment. I think it's this one. Okay, so in this assignment, so write the code for each item that produces table of x and y values for the following. So in here, we're just going to simply display or print the values for x and y's, okay? So for the x, we already have the values, which is 5, okay, to 10. So it's incrementing by 5, so we expect 5.5, 6, 6.5, 7, 7.5, and so on and so forth until we reach the maximum value of 10. Okay, and then for the y, okay, so this is where we solve for the value of y. So let's say the value of your x is 5. What is the result of y? If the value of x is 5.5, what is the value of y? Something like that. Okay, so we will display that one using a looping statement. All right, so let me just delete this one. So in here, we're going to display them, okay, inside of a data grid view. Well, you can also display them using a list box, but in my case, I will display them inside a data grid view, okay? So I just declared two variables, okay? So the x and y, and then we have this function clear so that we can clear the items inside of the data grid view. So every time that you will click this button, it will clear first before it will display the items inside. Okay, so we don't want the values to be overlapping with the next values. All right, so for this one, when we say columns, data grid view dot columns, it is the title. Okay, so we have here the header or the title, the x and y, and then the first parameter is the values below it. Okay, so of course the title is x, so we need the values of x. Okay, wherein it will be coming from this x right here. So we have to change this one since the initial value is 5 and then the ending value is 10. And this one is correct since it is incrementing by 0.5. Okay, and this is the only thing that we need to put. Okay, which is coming from here, the formula of y. So it's 3 times x raised to 5. So let's put that one for now. 3 times x raised to 5 minus 3 times x raised to 3. Okay, and then plus x. All right, and then for this one data grid view that rows, so this is where we are displaying, okay, the values each row. So the first one is of course x, which will be displayed on the first column, and then the second row is y. I mean second column is y, which will be displayed on the second column. Okay, so yeah, that's it for this example letter A, or number one. Example number one, or assignment number one. Okay, so for the components, so I just have two components, the button and then the data grid view. So let's test this program. Okay, so just wait a second. All right, so if I click compute, it will display here the values of x, which is from 5 to 10, and then their values, respective values. If we have the value 5 using this formula, okay, we'll get 9,005. If we have 5.5, we'll get 14,604.91, and so on and so forth, okay, up to 10. All right, so yeah, that's how we answer this assignment right here. And then for the number two, so all we need to do is change the starting point, which is now 1 and then 3, and then change the formula, okay, which is 1 plus x squared divided by 2, and so on and so forth. So let's try to answer number 2. So this one is ranging from 1 to 3. So starting from 1 and then ending on 3. And then the formula is 1 plus x, 1 plus x plus x squared divided by, so let me copy this one, plus x cubed divided by 6. So x cubed divided by 6 plus x raised to 4 divided by 24. So 4 and then 24. Okay, and then the rest are the same. Okay, for the incrementation, so it's still 0.5, so we don't need to change this one anymore. So let's test this program. So for you to be able to verify the values of y, so you can use your calculator, of course. Okay, so if we have, let's say 1, is this correct? If we have 1.5, is this correct? And so on and so forth. Okay, so you can try the experiment wherein you can, of course, uh, let's see, increase the ceiling up to 10, not just 1 to 3 or 1 to 20 or 1 to 50. So that's completely depend on you. Okay, if you want to display up to that count of numbers. So did you guys get the idea so far for this assignment, number one and number two? What about the others? Okay. All right. So great. So I will not answer number three anymore since this one is super simple. Okay. So all you need to do is change the formula into this one, and then change the starting number from 4, and then the ending number is 10. And then it's incrementing by 0.2. Okay. So yeah, that's it for this assignment. Let's now proceed to the next one. So in here we have exit do, we have exit while, and then we have exit for. So before we don't have this one, but in here it's like we have another condition. Okay, so in here we have this condition wherein we already know that the minimum value or the starting point is 1, and then it will end at exactly 10. But since we have this condition right here wherein if x is already equal to 5, it will already end the loop, or it will force close the loop. Okay, so meaning this will override this condition right here. Okay, because this condition were met, so we have to execute this exit do right here. So this one is for do while loop. Okay, so that is exit do. But for the exit while, okay, or the while and while, okay, we're going to use exit while. So we still have the same, just a different syntax, okay? So in here we have exit 2, but in here we have exit while. So depending on the structure, that you are using. Okay, and then we also have exit for, which is for the for next structure. So again, instead of this one is going to loop 10 times, this will now only loop 5 times, okay, because it will force close at exactly 5. All right, so all of those three are just the same. They have the same functionalities. It's just that they have their own syntax depending on the looping structure. Okay, so are we clear so far regarding with this additional function? Hello, 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 guys. You guys still around? Did you guys get this one? On what is this exit to do in this code right here? All right. Okay. So maybe you're wondering why we only have three. We only have exit do, exit wall, and then exit for, but we have a total of six looping structure. So that's because they don't have those kind of uh, exit statement or exit function. So if you want to force close something, then you can use uh, for next structure. You can use while and while structure, and then do while loop structure. Okay. And then we have here another assignment wherein write a program that outputs the sum of the following using while looping statements. So let's do this one. Let me just get the created sample of this one. All right. So let me remove that one. And then in here we have write a program that outputs the sum of the following using while looping statements, wherein we have a summation from 1 to 100. Okay, so if we're going to search that one on the internet, uh, what is the summation of 1 to 100? So this will give us a result of 5050. So we should have the same output if we're going to do that one on the Visual Basic. So for us to be able to do that one, we have to declare two variables, the sum and then the counter. The counter is your a number, of course, that will count from 1 to 100. Okay, that is why it's being initialized right here. Wherein, of course, initially you will start with 1 and then you will end at 100. Okay, and then for the sum, this is where we are going to store the values and every time that it's incrementing. So of course, initially the value per sum is 1. Okay, because that is the uh, initial value, okay, which is the counter. And oops, right here we have to add the counter value. All right, so initially our value of counter is 1, so it will be placed in here. And then in here we now have a value of 1, so this one will increment by 1, so the counter now is 2, so 2 plus 1 is now a total of 3. Okay, so every time that we will increment, it will be added onto our last or the previous value. Okay, so with that, we'll be able to get the summation from 1 to 100. All right, and then whatever is the final result, okay, after this loop right here from 1 to 100, it will be displayed inside of a message box. Okay, so in here, this is already correct. So let's see if we have the same result. So we should, yeah. So we have a result of 5050, okay, which is the summation from 1 to 100. Okay, so that's the answer for the letter A. What about letter B? So still we have a range of number from 1 to 100, but in here now, I is divisible by 2. Okay, meaning we will start with 2, 4, 6, and then so on and so forth. So it's like basically we have even numbers only, ranging from 1 to 100. And then if you're going to search that one on the internet, we will get 2,550, I guess, if I'm not, uh, if I'm correct, okay? If I'm not mistaken. So let's see. So in here, we can actually do some tricks. So for us to be able to display even numbers only, so we will start with 2, but still the ceiling number is 100, so that's the maximum. Okay, and then instead of incrementing by 1, we'll increment that 1 by 2, so that we can only have uh, even numbers. Okay, that is keep on counting or keep on incrementing. So let's see what is the result of this one. So in here we have, yeah, 2,550. So just search this one on the internet or just solve this one using a certain formula. Okay, so I'm pretty sure that this was already discussed by your teachers before, on how to get the summation of a certain uh, number. So yeah, that's it for the number 2. Can you guys follow so far for the letter A and letter B? Okay, great. What about the others? Do you guys have a question so far? All right. Okay, so if you guys don't have questions, so let's now proceed to letter C and D. So for the letter C, we have another formula right here wherein the number will be squared, okay, every time that it will increment. So initially is 1, so it's 1 squared, followed by 2 squared, 3 squared, until you reach the value of 10 squared. Okay, so let's do that one. So initial value is 1, ending value is 10, and the counter is still incrementing by 1. So in here, this one was being squared. So let's see what is the result. So we will get a value of 385. So that's the summation from 1 squared up to 10 squared. All right. And then for the last one, we have here 1 over 2i. Okay, so we're getting the summation of 1 half, 1 fourth, 1 sixth, and so on and so forth. So in here, all we need to do is put the counter, okay, 1 half, and then multiply this 1 by 2. And in here, we have a range of 1 to 5. So 1 to 5, and it's incrementing by 1, still by 1. All right, so let's see what is the result. So one more thing, you have to declare this one as a single, okay, not integer, because if you will declare that one as an integer, then you will not be able to display if it has a decimal point. So in here, we have declared this one as single so that we can see what is the decimal point. So in here, we're having a result of 7. Is this correct? 7.5. Isn't it that we should be getting 1 half plus 1 fourth? Yeah, I think it's correct. One. It's like it's not correct. Let me just check. 1 half plus 1 fourth plus 1 sixth plus 1 eighth plus 1 over 10. This one is incorrect. The correct answer is 1.14. Okay, let me just check what happened right here. I see. So as you guys can see, this one right here, we have 1 half, but this one is being multiplied on the numerator. So what we want is this counter should be at the denominator. Okay, so let's revise this one into something like this. There you go. So that we can have a numerator times numerator and then denominator times denominator. So yeah, there you go. So this is the correct answer, 1.141667. All right. So were you guys able to follow for this assignment right here? Okay. All right, so great. So again, if ever that you have a question, so feel free to ask me anytime, okay? All right, so let's now proceed to exercise number 9. So in here, we're being asked to make a program that computes the distance a body falls in feet per second for the first 5 seconds of the free fall as given by the equation. Okay, so for the distance, we have this formula, 1 half times acceleration times time squared. So this distance right here is in feet, okay? And we have here the expected output, wherein if we're going to do that one manually, we have 1 to 5 right here for the first 5 seconds. And then we have here the equivalent distance traveled after 1 second, after 2 seconds, after 3 seconds, and so on and so forth. All right. And then here's the code for this one. So again, I just declared two variable, okay, because those are the only outputs that we need. We have the time, which is the first column, and then we have the dist or distance for the second column, and then we have we always have this function. This will never be begun, okay? So we must always have a that clear function for us to be able to clear the items inside of the data grid view before it will display the values or variables. All right, and then we have here the titles. So as usual, if we say columns, okay, those are the titles. We have time in seconds, and then we have distance in feet, okay, and then the values below them, okay. So here's the values for time. So it's ranging from 1 to 5 right here. And then we have the formula for distance, which is 1 half times 32 times time raised to 2. So this 32 right here is a default value of acceleration. So you can recall that one if you have already finished your physics, or you can just simply search that one on the internet for you to be able to check if it's really 32 or not. Okay. And then in here, we are now displaying the values row by row. Okay, so that is why we are declaring here that rows that add. Okay, so for the first column and then the second column. And then we are formatting the result of the distance right here. So that is why we are having a fixed value of 2 decimals. And even though it doesn't really have a decimal, it is showing a 0.00. Okay, that's the function of this fixed value right here for the letter F. All right, and then of course it's incrementing by 1, okay, so that we can see all of the values from 1 to 5. So for this one, exercise number 9, let me just show to you guys the result. So I have the same code, I just copied whatever we have in here, and then I have the same components, a button and then a data grid view. So let's test this program. So calculate. So in my case, I have a time from 1 to 10, not 1 to 5. And then of course, this is the corresponding distance traveled. So 9 is already 1,296 feet. And then 10 is 1,600. All right. So that's it for this example or exercise number 9. So is this clear so far? So if you're not getting it, like what's happening with this code right here? So you might want to try this one on your own. So just try to copy this one and then paste it on your Visual Studio, make it work, and then try to make some changes. Just for you to be able to appreciate what are things that you can do and you cannot do in here. Okay, as long as you're following the correct syntax, and I think you're good to go. Okay, you can expand this more if you wanted. Okay, you can add another columns, you can add more formulas, more computations, and so on and so forth. But anyway, yeah, that's it for the exercise number 9. And then we have here exercise number 10, which is much more complicated than the previous example. So the x and y coordinates as function of time p of a projectile fired with an initial velocity v at an angle theta with respect to the ground is given by. this formula right here. So for the distance traveled, we have velocity times time times cosine times theta. And then for the height, okay, which is y, so it's equal to velocity times time times sine times theta minus 1 half gt squared, or gravity times time squared. So using these formulas, write code that allows the user to input for the initial velocity, let's say 350 meter per second, at an angle, say 25 degrees. So we have here an initial values, let's say, just for saying that we have this result right here, but you can put any acceleration or velocity that you want, okay? And then you can also put any degrees that you want, okay, for the angle. So display a table of x, which is the distance traveled, and y, which is the height values for a projectile fired at a time interval 0 to the total time of light. Okay, that is t is equal to 2 times voltage, 2 times velocity times sine theta divided by gravity. Okay, seconds with increment of 1/2 second. So hint, remember to convert to radian measure. So uh, in here, we have the sample output. Okay, we have the initial input, initial angle, and then we have here the computed time of flight. Okay, and then the expected output. So for us to be able to come up with this one, so all you need to do is analyze this solution right here. So we have declared a total of 7 variables. Okay, so for these 6 variables, so we have declared that one as single because so if it's single, then it can maybe, okay, there's a possibility that it will display a decimal. And then for the letter G, this one is actually a fixed value, which is gravity is equal to 9.81. So that's the gravity here on Earth. So if you're doubting the value of this one, so feel free to search this one on the internet. So G is equal to 9.81. And then we have these two inputs right here, wherein the text box one is the velocity, and then the angle is coming from text box 2. All right, and then again, we have this clear function right here, and then we have the titles, and then their corresponding values, and then the formula for T flight. So where this one came from? It came from the instruction itself. So T flight, or T, is equal to 2 times velocity times sine theta divided by G, which is now this one, 2 times velocity times mat that sine radians angle divided by G. So if you guys are going to take a look at this one, so it says radians. So we must multiply this angle right here to mat that pi divided by 180. Okay, so that's the way for us to be able to obtain a radian uh, value, okay, of an angle. And then we have here the text box tree, the text wherein it's displaying whatever is the result in here. It will be displayed on our text box tree, the text, okay, ETF flight. Then again, we have a format right here. So again, if you're still not familiar with the format, so just go back with our module 7. So we just look for the table about formats. You will see there the fixed format, N1, N2, 0.00, 0.000, format for dates, format for a peso sign, dollar sign, and so on and so forth. Okay, so N2 meaning we are only getting 2 decimals. Okay, just like what we have in here. Okay, and then the same for the flight. And then we have the continuation of the solution. So we now have here the looping. Okay, so initially we'll start with 0, and then we'll now compare that one if it's already lesser or equal to the t flight. So in here, if it's not equal with the t flight value, it will never stop looping. But once it is equal to the t flight value or less than, then that's the time that it will stop looping. So we have here the formula for the distance. So again, it came from the instruction itself. This one right here. It's cosine theta. And for the height, we have sine. Okay, mat that sine right here. So for the radian, again, we have to multiply that one into mat that pi divided by 180. Okay, and then we in here we have here the values for every row. So the first one is the time, followed by the distance, and then followed by the format followed by the height. Okay, and then we have formatted for the result of this one, so we're getting fixed value, okay, or the two decimals only. And then for the time, it's incrementing by zero point 0.5. Okay, so where this one came from, it came from the instruction itself. So 1/2 second. Okay, and we have here additional. Okay, so in here this will display the final value or the final row. Okay, because if we only have this loop, okay, this will never show the zero. Okay, zero height of the row. So that's the reason why we have like additional, okay, competition right here, which is outside the looping. Okay, so this will compute for the final row. So you will see later on what is this for. But anyway, for this one, let me just open why new project. Should be open project, and this is number 10. Number 10. All right, so whatever we have in there is the same with what I have in here. So for the radian, again, we just have to multiply the angle into mat.pi divided by 180. Okay, and then the rest are the same. Okay, except for the naming of data grid view. So just change that one into whatever is the name of your data grid view right here. And then for the interface, of course, I've just copied whatever is in there. So we have two labels, I mean three labels, I mean four labels. Okay, one, two, three, four, and then three text box, and then one button, and then a data grid view. So let me show to you guys the result. So let's say 350 and then 25. So we have the same result. So time of flight is a total of 30.17. So it is the final value of this one, okay, for the time of flight. Okay, so it will only stop if it's already equal, okay, with this one right here, 30.16655. And then for the final row, okay, where is that one right here? Okay, for the final row, so it's being computed by this one, okay. So if we don't have that additional competition right here, we will not be able to see this 0.00 right here. All right, so that is the reason why we have this one outside the loop. Okay, because if it's not, then it will only reach up to 30, which is 24.50. And then if you want to get the peak value, so it's at the mostly it's at the middle, which is 15. Okay, so we have 1115 is this meters or feet or whatever's the unit. So this is the peak that it reached, and then the distance, total distance traveled, is 9,569.06. Okay, and then the time of flight is 30.17. So yeah, that's it for this example. So are you guys able to follow so far? So it's okay if you didn't get this one. So I know that this one is quite complicated, but if you want to understand this one, so your only choice is to do this one on your own. So you have to redo this one using your own Visual Studio and then play with it. Try to change the maybe the name of your variables. Try to change this one into entry for you to be able to get the three decimals, and then try to change maybe the formula of the distance, formula of height, and so on and so forth. So whatever you can do, just play with it. Okay, with that you'll be able to learn more on how this code right here work. All right, so that's it for now for the part one. So we don't have enough time anymore, so we'll just continue the rest on the part two. So goodbye for now and see you guys later.